All right, this is lesson 5.3 again, the slope-intercept form. This is part 2. You're going to take some notes just like you did before using your notebook, pencil, and a ruler, and you can just continue on the same section of notes. You don't have to start a new section or a new set of Cornell notes. I took the time to split this lesson into 2 parts because the problems I'm going to show you today are kind of complicated and there are a lot of steps. So I want to just focus on 2 types of problems. And here's the first type. So in your notebook, you can write down problem 4 and go ahead and copy these 2 sets of coordinates. The question asks what equation in slope-intercept form represents the line that passes through these 2 points. Now you remember that the slope-intercept form is y equals mx plus b, where the m is the slope and the b is the beginning point or the y-intercept. But all you're given are 2 points. You have to actually figure out what the slope is and what the y-intercept is just by these 2 points that are given. So you also learned in a previous lesson how to calculate the slope using the formula y2 minus y1 over x2 minus x1. So your first step in this problem is just to take the 2 coordinates and label them with the x1, y1 and x2, y2, and then calculate the slope. y2 is negative 3 minus y1 is negative 2, and that's being divided by x2, which is 1 minus x1, which is 3. Negative 3 minus a negative 2, the minus a negative becomes plus a positive, so negative 3 plus 2 is negative 1, and 1 minus 3 is negative 2. Negative 1 divided by negative 2 is positive 1/2. So in order to write this equation, you need to know the slope and you need to know the y-intercept. You've calculated the slope. Now you just need to figure out what the b is, what the y-intercept is. And this is where it becomes a little bit tricky. In order to figure out what b is, you're going to take the equation y equals mx plus b, and you're going to substitute values into this equation and solve for b. So you're given 2 sets of points, 2 sets of coordinates in the beginning. All you have to do right now is pick a set. I'm going to pick the second set because it looks easier to me. And in that second set, 1, negative 3, that represents an x value and a y value, or an x coordinate and a y coordinate. I'm going to take that x coordinate, which is 1, and I'm going to put it in the equation in place of the x. And then I'm going to take the y coordinate, which is negative 3, and I'm going to put it into the equation in place of y. I know what my slope is because I just calculated it. It's 1/2. I'm going to replace the letter m in the equation with that value 1/2. So I've taken my x coordinate, my y coordinate, and put it into the equation. I took my slope, which is 1/2, and I've replaced every letter in the equation except for b. And now I can solve for b to figure out what my y-intercept is. And I do that by multiplying 1/2 times 1. That gives me 1/2. To solve for b, I'm going to subtract 1/2 from both sides. And I get b equals negative 3 minus 1/2 is negative 3 and 1/2. So let's review. I started with 2 points. I calculated the slope and I found that it was equal to 1/2. Then I chose one of the sets of points. I chose the second one, and I used those x and y values in the equation y equals mx plus b to calculate what b is. Now that I know what my b is, I can write an equation by writing y equals mx plus b. The m is 1/2 mx plus my b is negative 3.5. And that's my equation. Now I could write it with subtraction instead of addition. So y equals 1/2 x minus 3.5. Either one of those is correct. And now you see why I waited until part 2 to show you that problem. Okay, the second problem that I'd like to show you is problem 6. And it's just a story problem that models a function y equals mx plus b. In this problem, it says water pressure can be measured in atmospheres, that's ATM. Use the information in the picture or the diagram to write an equation that models the pressure y at a depth of x meters, and then graph that model. So if you look closely at this picture, at the top it says at 0 meters the pressure is 1 ATM. What this really is telling you is that in the beginning, or the B, the pressure is going to be 1. So by looking at the diagram, I can figure out that my B, or my beginning point, is 1. Toward the bottom of the diagram, it says the pressure increases by 0.1 ATM per meter. This increase in pressure per meter is the rate. That's the rate of change or the slope. So the second part of this diagram tells you that the rate is 0.1. Now generally when you write a rate, you're going to write it as a fraction, not really as a decimal. So I'm going to write 0.1 as 1/10. So because I know what my beginning point is, and because I know what my rate of change or slope is, I can write an equation that looks like this. Y equals mx plus b. And that's it. To graph that equation, I'm going to use the beginning point, which is 1. So I'll move up on the y-axis to 1 and put a point there. And then I'll use the slope, which is 1/10, which means up 1 over 10. So I'll go up 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now a good graph would consist of more points than that, but since the numbers are so large, I'm just going to use the 2 points, and that's my graph. So I'd like to do one more problem, and that problem looks like this. It says a plumber charges a $65 fee for repair plus $35 per hour. Write an equation to model the total cost y of a repair that takes x hours. What graph models the total cost? Now, you kind of have to understand how businesses operate, or plumbers operate, or repairmen operate. Usually they'll charge you a flat fee just to show up at your house. In this case, the plumber charges a $65 flat fee. And then once they get there and they look at your problem, then they're going to charge you a rate. And the rate is usually per hour. And that's what this plumber charges, $35 per hour. So the flat fee, or the startup cost, or the fee that they charge you just to show up, is really the beginning cost, or the beginning point. So in this problem, the beginning cost is $65. And the rate that they charge you after that, that's the rate of change, or the slope. So for this problem, it's $35. So from the information in this problem, I've learned the beginning point and the slope. I can write an equation. Y equals mx plus b. That's the equation that models the total cost y of a repair that takes x hours. Now I'm going to skip the graph for now and show you that in class, but I do want to show you how you can use this equation. If the plumber shows up and has to work at your house for 2 hours, how much will that cost you? Well, y represents the total cost, and x represents the hours. So if a plumber shows up and works for 2 hours, I can put 2 in place of the x and use the equation to calculate my total cost y. 2 hours times $35 per hour is 70, plus the $65 just to show up. 70 plus 65 is 135. So the total cost would be $135 for 2 hours. And that's it. So be ready tomorrow. Come with questions on some of the problems that I've shown you. If you don't understand, it would be a good idea to go back and watch the video one more time without taking notes and just see how I've worked through the problems. And if you still can't get it, ask me questions in class tomorrow.